Okay, here in this course we only do curves of polynomial functions only. We only look at polynomials like maybe parabolas, cubics, the power 4, so on. Because it's first year course anyways. So, but we will not look at rational functions like maybe if I ask you to draw the graph of this, for example, y equal to that. See, here you still have to use derivatives to get the asymptotes, because obviously there will be an asymptote here. If x is 1, if it's negative 1 is 1. And then you have to now look at how will the graph behave in certain intervals. From this asymptote to the other one, how will it be? So it's a lot of work in this case. But if you are interested, that book that I have given you, the calculus book, there's everything. There's everything. So here, in this course, we will only do polynomial functions. Okay, so what we need first of all, the y-intercept. What is the y-intercept? What is the y-intercept? What do we mean by y-intercept? Where the graph cuts the the point where the graph cuts the y-axis. And how do you get the y-intercept?
You equate x to 0.
So the value of what? This is the value of y when x is equal to 0. So that is the point where the graph cuts the y-axis. X-intercept can be more than one intercepts. So that is the values of x. So obviously that is where the graph cuts the x-axis. Okay. And then let me just ask you something here. What is the y-intercept in this case? For this one. So y-intercept 1. This is 100% wrong. I will not give you a single mark there. So everybody listen to me, don't do this. Huh? What you must do is, because we are saying that this is the value of y, you have to write y equal to 1.
No.
It is the value of y when x is 0. So you must put y is equal to 1. If you just write 1 there, you get a 0 for the 1 there. Y equal to. Or if you want, why don't you just give it to me as a point? Maybe this will be much better. It's 0, 1. Coordinate notation. So you're giving me a coordinate notation, much better. So for x, same story. X equal to. Okay? Alright, number 3, the critical points. The critical points, these are the points where the critical points in this case are points where the derivative is either 0 or it does not exist. DNA stands for does not exist. Either it's 0 or it doesn't exist. But in this case, now if we are only dealing with polynomials, there is no way that derivative does not exist. So we only look at so in this case, we are only dealing with either maximum minimum turning points and also the points of inflection. Points of inflection. And at this point, big man is looking at this. Did you understand what is happening?
Yes, I do understand, sir.
So what is the point of inflection? Big man understands, but then he cannot answer. So you know what the point of inflection is? Some like parabolas don't have point of inflection. So the point of inflection is a point where the curve, like cubic functions, you see sometimes it goes like that. Somewhere there. See, it was curving up, then it starts curving down. At that point where it starts curving down, that is what we call the point of inflection. So it's now changing its curving. So that is what we mean by the point of inflection. point where the graph change is curving. So if it was concave, concave is reverse, you start convex. That's the way it changes, or from convex to concave. Okay, so at the maximum turning point, the first derivative is 0, and this is the equation that you use to get the x coordinates of the turn of this maximum turning point. Okay, now if you want to determine is it maximum or minimum, because at minimum also, first derivative is also 0. Not just maximum of the turning point, of any turning point, irrespective. Irrespective of whether it's maximum or minimum, but this you get all the coordinates, the x coordinates for the points, for the turning point. But then now to check if it's maximum or minimum, you use the second derivative. If it's maximum, so if you take the x coordinate and substitute it in the second derivative, then you realize that the answer that you get is negative. Then you know it's a maximum turning point. Substitute the x coordinate that you got here. Now you check. Let's say you got x coordinates to be maybe the first derivative dy dx is, let's say, 2x squared minus 3x plus 1. Is it possible? Yes, then you get the turning point. X is equal to a half, or x is equal to 1. Okay? And then you now have to take this and substitute it in the second derivative. What is the second derivative in this case? 6x minus 3.
6x, 4x.
Ah! Right. Good. Checking you. Then you now substitute it. If you substitute the half where x is, so what do you get? Half of 4 times a half minus 3. So that is 2 minus 3, which is negative 1. So then you know that this is the x coordinate of the maximum turning point, because the second derivative there is negative. If you substitute 1 here, you get 4 minus 3, which is positive 1. So that means there we have a negative. Very good. Okay, so we have a minimum. So at minimum, so the first one, that is the one that we used to get the x coordinates, and then second derivative is used to check if it's positive, then you know it's minimum. That's the point of inflection. Point of inflection. To get the coordinate, the x coordinate of the point of inflection, you just equate the second derivative to 0. So remember what the point of inflection is. What is it? The point where the curve changes
direction.
it changes its curvature. So points so that means that there or okay. I think I've talked enough. I have written enough. And he has recorded enough. And you have been quiet enough also. It's time to talk now.
So,
Kuala.
did you start with our